Welcome to Quantum Physics 2 for summer 2020. This short presentation focuses on the overall view of the course and gives you some idea of what to expect. I will have a second presentation for this class, this first class, that will actually deal with some technical aspects. So, this course addresses useful and important applications of quantum physics and should help you to interpret current developments in the context of quantum physics so that you can get into research. The idea is that this is an overview course so that you get some idea of what various topics in quantum physics and in physics might be and what might interest you. And then I strongly encourage you to take the appropriate 4000 level courses if you find a topic interesting. We have 4000 level courses in particle physics, astrophysics, more advanced quantum physics, computational physics, and solid state physics. So there are plenty of opportunities for you. The topics that we're going to address in this course, again, are quite broad. I'm going to review some of the material from the course that you previously took, Quantum Physics 1, because it actually helps you to learn that material a little bit better if you see it a second time. But in particular, I'm going to make a point now of addressing some of the topics that you previously learned using computational tools. And in particular, I'm going to introduce you to, if you haven't seen it already, to the use of Python as a computational tool. In particular, the libraries and modules within Python that are quite useful for physics computation, and those include NumPy, SciPy, and for plotting, the mathematical plotting utility Matplotlib. So this is not a computation course, but I will attempt to give you enough of a background so that you can use basic computational tools to do calculations. I might say that I have described myself as a 5 or a 10 function, 10 command programmer. That is, I figure out what I have to do, then I have an idea of the structure and what I can do, and then I look up whatever I need in order to actually program. I'm going to be encouraging you to copy and paste functions that you need to use in this course. So I don't expect you to be able to code from scratch, but you should be able to look at something and understand what is going on. So along those lines, then, we're going to review solutions for one-dimensional potentials. Maybe I'll give you some insights that you didn't have before. And then we're going to review spherical potentials, in particular the solutions for the hydrogen Coulomb potential. And then we will move on to what I hope will be new topics for you. When we study atomic wave functions and try to understand what's going on in quantum mechanical systems, one of the primary tools that we use is the electromagnetic interaction with the system, in other words, optical transitions. And understanding what transitions are allowed and what transitions are not allowed to first order, at least. Those things are called selection rules, so we'll talk about that and the origins of selection rules so that you have an understanding as we're talking about spectroscopy, what it is that we were actually measuring. Then we go off into some significantly new and subtle topics. Everything that you did in Quantum Physics 1 addressed dealing with a single particle or a stream of particles that were not interacting with one another and were not in a single quantum mechanical system. Now we're going to worry about what happens when we put more than one particle into a system. So number one, electrons interact with electrons through Coulomb interactions. But then in addition, when we add the idea that two particles can be indistinguishable from one another in a quantum mechanical system, that imposes limitations on the system that have actually profound effects on the behavior of systems with more than one particle in them. And then we'll do some calculations with systems of more than one electron. That will then take us to the idea of the statistical distributions of particles within systems. There are two classes of particles. There are fermions, and I'll talk about that later, where one of the rules is that only a certain number of fermions can occupy any given state function, and bosons, where the rule is that you can put as many bosons as you like into a particular state. From there, now we've put together this concept of identical particles and statistical distributions. We can talk about the structure of molecules, the electronic states of solids, and applications in semiconductor and metal conduction. Then at that point, we will shift gears into probes of atomic scale systems, and in particular scattering experiments. And in order to understand scattering experiments, normally we have to understand, and interactions between fundamental particles, we have to have some understanding of special relativity as it applies to those systems. And then we will finish up with particle physics and nuclear physics. The course structure is different from what it's been in previous years. This course is going to be conducted online, entirely online through the summer. I expect that we'll have about 12 weeks of classes, and I am setting the schedule to be consistent with that. The recordings of lectures, such as this, will be posted, I say at least 24 hours, I've already broken that, but about 24 hours before the real-time synchronous class. And what I hope that you will do, I expect you to do, the course will be predicated upon it, is that you're going to view the recorded lecture in advance of the real-time synchronous class, which is on Tuesdays and Fridays from approximately 4 to 6. And you're going to come to the class prepared to ask questions and prepared for discussion. So this is almost like a seminar class where you read the material, you come with some understanding of the material, and then we talk about what it means. So there's going to be a lot of discussion in this class, a lot of questions, I hope. The actual synchronous real-time class time will be focused on answering your questions, working problems, and we're going to have a quiz every week. That decreases some of the pressure that you would find on comprehensive examinations. We'll still have comprehensive exams, a midterm and a final, but they won't count for as much in the course as they might otherwise. The weekly quizzes will usually be given on Tuesdays at the beginning of the class, and they'll be related to work that was due in the previous week. So you turn your homework in typically on Fridays. We discuss that work on Fridays. You have some time to ask questions. I have office hours on Monday, and then there's a quiz on Tuesday that's related to that work that you just went through and you got some feedback on. Then finally, as far as grading in the course, homework is a very significant part of the course. Your learning is based not only on being able to solve the problems, but being able to explain how you solve the problems. And so it is 45% of your grade in this course. The homework will be posted for you, and then there will be a submission site set up for you through the Blackboard Learning Management System. And the homework is usually going to be due on Fridays. Although, depending upon scheduling during the summer, I might shift things around so that you have time to do other things. As I had mentioned, there will be topical quizzes in this course. They're going to count for 30% of the overall grade, and comprehensive midterm and final exams that are going to count together for 25% of the grade. So about half of your exam grade is in quizzes and half of it is in the comprehensive exams. Exams and quizzes will be open book, open notes. However, you're not permitted to interact with one another. That is, exams and quizzes are not team efforts. Other things, activities in class and homework, are permitted to be team efforts. However, you should be careful not to simply copy from one another. But the exams and quizzes will be open book, open notes, but no open collaboration. The exams and quizzes will be timed, 30 minutes for quizzes, 2 hours for the midterm, and 2 hours for the final. And all of these will be held during the scheduled class hours. If you have problems with the schedule, then you should be talking with me about this so that we can make arrangements for you. I have already talked through most of this, but I just want to be explicit about it. The overall grading rubric is this: homework. There'll be about 10 homeworks, counts for 45% of your final grade. Your grade in the homework depends upon both being able to solve a given problem and being able to explain how you solved that given problem. So clarity in explanation is very important. The quizzes and in-class activities, there'll be about 10 of them, will count for about 30% of the grade most of the time. The quizzes will be on Tuesdays, and we might or might not have in-class activities both on Tuesdays and on Fridays. And the midterm and final examination are such. The final examination is going to include 3 components. Actually, the midterm will include 2 components. That is a multiple choice and a written free response answer portion. And those will be graded separately and posted separately. The final examination will also include an oral presentation, actually an oral problem solving. So I will meet with each of you in the class for approximately 15 minutes and ask you to solve a problem for me, to talk your way through a problem. The nominal cutoff for grades, nominal cutoffs are given here. They're fairly standard with me stretching downward a little bit. I will comment that if a student, that is you, are making a serious effort in the course, doing the things that you should be doing, handing in your homework in a reasonably timely fashion, and demonstrating that you have some sort of clue on the exams, no matter what your actual grade on the exam is, then you will not receive a grade below C- in the class, more typically C for the student who's doing everything the way that they should be doing things, independent of what your actual score on the exams is. So don't worry about whether you pass this course or not. Worry about learning the material. In addition, I don't curve in any way. So, by the way, curve means that you impose a certain distribution of grades on the class. If it turns out that everyone in the class nails this material and does great, then everyone gets A. If everyone screws up, then everyone gets C. Although I would say that if all the grades are low in a class, then I usually look at myself and ask whether I did an appropriate job of conveying the information to you. The resources in the course, I just want to list them here briefly, include number 1, the textbook. I'm going to repetitively tell you throughout this course to read the textbook. For one thing, I make mistakes in the lectures, and they don't have very much in the way of mistakes in the textbooks. All of these are in later editions, so typos have been fixed, and the explanations are quite clear, I think. Townsend and Crane take different approaches to the material that's in this course. Townsend is somewhat more theoretical and mathematical. Crane is more experimental. They cover the same range of materials. In this second course in the quantum physics sequence, it turns out that Crane is actually a more useful text for us. For one thing, it covers a greater breadth of material. However, I will be going back occasionally to Townsend because the mathematics is a bit more rigorous in Townsend. All the notes that you need for this course and a lot of the other material are going to be available through Blackboard Learning Management System. You should all have access to LMS, the Learning Management System. At this point, you should have been getting messages from us. If you're not getting messages through the Learning Management System and you can't access it, please let me know as soon as possible. I have included quite a bit of supplementary material in a resource folder in the Learning Management System. It includes original articles written by Pauli and Dirac and Einstein with respect to some of the material that we actually address in the material, as well as what I deem to be the best chapter in a modern or quantum physics textbook related to certain material. So there are several different books that I have gleaned individual chapters from, and I have posted them in the supplementary reading section here. You are not required to read that material, but if you're interested in something, you will, or you're confused by the treatment in these two books, or by me, then you're encouraged to go look at the chapters that are stored in the resource folder. I actually encourage you to just go ahead and download the entire resource folder. Any course announcements or other important things of the course you're going to find through the Learning Management System, LMS. Homework is posted in LMS. Your solutions to the homework have to be posted into LMS. If you need to find out what the office hours are that were available, this is wrong, by the way. Already I've got a typo. My office hours are going to be Mondays and Thursdays, 3 to 4 and 4 to 5, approximately. Again, that will depend upon your feedback, whether you need it or not. And office hours for the TAs, facilitators, and tutors in this course will be announced through LMS as well. The resources I mentioned, and here these are correct. My office hours are going to be by reservation, again through WebEx LMS, for the hours from 3 to 4 on Monday and Thursday, and then I'll open up my WebEx room to anybody who wants to join. On Monday, Thursday, 4 to 5. I'll add hours as might be needed. The graduate teaching assistant who will do most of the grading for this course is Mark Hackel. His office hours will be posted, and the two undergraduate tutors and facilitators, learning facilitators for this class are Susanna Jedlinska and Luke Brezak. And I might mention that Susanna is my maven for Python and Jupyter Notebook programming, and I think that she will be a very good resource for programming for you as well. Both Susanna and Luke will be helping you through the material of the course and can be prepared to discuss homework as we go along. Their hours will be posted in LMS.